Assalamu alaikum. Welcome to this multi-sim software tutorial. Today I am going to teach you how to design DC series circuit or resistances in series in multi-sim software. For this purpose I have considered an example as shown in the figure. The figure shows DC series circuit consisting of 3 resistors across a 24-volt battery. We have to calculate the voltage drop across each resistor and current flowing in the circuit. Furthermore, we have to prove that the current in the series circuit remains same. Friends, for your convenience, I have uploaded the mathematical solution of the example in the form of PDF link in the description section. You can download it from there. Let's start. Just click on this multisim icon to open it. As we need the various components such as resistors, voltage source, voltmeter and ammeter to design the circuit, therefore just click on this icon having the name place and then click on component. You can see a new window is open. In the group section, click on basic and then select the resistor block and press OK. As you place this resistor, the same window will be automatically opened for your convenience to take other components. However, you may close it if you do not want to take any component. As we need 3 resistors, therefore easiest way is to select this resistor, then copy it by pressing Ctrl+C and paste it here by pressing Ctrl+V. Similarly, repeat the same procedure for the third resistor. Now we need DC battery. For this purpose, go to place block and click on component. In the group block, select the sources. Then in the power source category, click on DC power and press OK. Now we need voltmeter. Therefore again go to place, click on components. In the group section, click on indicators and select the voltmeter and press OK. Double click on this voltmeter, click on display, then click on component specific visibility setting and uncheck the show values and press OK. Now double click on this battery V1 and write it V only to represent the total voltage. Now double click on this voltmeter and in the label section write V1 to represent the voltage drop across resistor R1 and press OK. Similarly, repeat the same procedure for V2 and V3 in order to measure the voltage across resistor R2 and R3 respectively. Now we need ammeter. Therefore again go to place, click on components. In the group section, click on indicators and select the ammeter and press OK. Double click on this ammeter, click on display, then click on component specific visibility setting and uncheck the show values. In the label section, write I to measure the total current in the circuit and press OK. Similarly, repeat the same procedure for I1, I2 and I3 in order to measure the current flowing through resistor R1, R2 and R3 respectively. Now we have to connect all these components in series connection. It may be noted that ammeter is always connected in series to measure the current. Therefore, connect this battery with this ammeter. Now connect this ammeter with resistance R1. Again connect the ammeter I1 with resistor R1 and R2 in order to measure the current I1. Similarly, connect the ammeter I2 between R2 and R3 to measure the current I2. Similarly, connect the ammeter I3 between R3 and battery to measure the current I3. At this stage, all the ammeters are properly connected. Now we have to connect the voltmeter in order to measure the voltage across resistance R1, R2 and R3. It may be noted that voltmeter is always connected in parallel across any resistance to measure the voltage drop across that resistance. Therefore, connect this voltmeter V1 across the two terminals of resistance R1 to measure the voltage drop across it. Repeat the same procedure to connect the voltmeter across resistance R2 and R3 to measure the voltage drop across these resistances. Now we need to put the correct values of the resistance and battery voltage as given in the example data. Double click on the battery and change the voltage to 24 volt and press OK. Similarly, double click on the resistances and change the values as given in the example data. Now we need the ground block to connect. For this purpose, go to Place, click on Components. In the group block, select the sources. Then in the power source category, click on ground and press OK. Connect this ground here. At this stage, our model is complete. Now we can run the simulation. To run the simulation, just click on this play button. You can see our model is working correctly. Now you can compare the answer with the answer obtained in the example. It can be observed that all the currents and voltage drops are correct. Furthermore, it is also proved that current remains same in the series circuit. Friends, in this tutorial I have discussed how to design DC series circuit or resistances in series in Multisim software. By doing the same way, any DC series circuit from any book can be designed in Multisim software and its performance can be analyzed. That's all for today's tutorial. I hope you really enjoyed this tutorial. Friends, I upload many videos based on various topics of power system and motivation on regular basis. Therefore, don't forget to subscribe my channel in order not to miss my latest videos. And don't forget to share my videos with your friends and class fellows so that they can also get benefit from these videos. Thank you very much.